Hello, dear students. I welcome you all to the third edition of online class on set theory, class 11 mathematics. So, before we begin with the topic for the day, let us start with a small story of 10 best friends. Okay, so I'm forming a set of my 10 best friends whose names are mentioned clearly here. Okay, and you might be thinking I have written all the names in lowercase or small letters because we know that each friend here acts like element of the set, and we know that elements are always represented using the lowercase. So that's the only reason that I have used the lowercase out here. Okay, now out of these friends, what am I going to do is I'm going to see who loves to play soccer, that is football. Okay, so let's say Alex, Cassie, Drew, and Hunter play soccer. Okay, now if only these four play a soccer, then I'm forming a set soccer. Name of the set is soccer, and within this set, the elements are the friends who plays soccer. All right, so it says that the set soccer is made up of the elements Alex, Cassie, Drew, and Hunter. Now you are quite familiar with this. All right, now see, among 10 only 4 are playing this, right? Now among these people, some of them loves to play tennis as well. Okay, so among these are the people, that is Cassie, Drew, and Jade. They loves to play tennis. All right, so this tennis is also a set, as you can clearly see that there's a curly bracket. Now tennis also acts like a set, and within this the elements, that is Cassie, Drew, and Jade, loves to play tennis. All right, now what am I going to do is I'm going to form two circles. Okay, and the two circles will contain the elements or the friends who play soccer, and in another it contains the people who loves to play tennis. Okay, now using this particular story, we are going to learn the topic for the day, and the name of the topic is operations on sets. And in this we are going to make use of something called Venn diagram as well. All right, now what is the meaning of Venn diagram? We'll understand very soon. So I've got two sets which I have formed earlier being ready out here. So the first topic for the day is union. Now what's the meaning of union? Let's understand using these two sets. So you can list your friends that play soccer or tennis. Okay, so out of those 10 friends, you want to see who plays soccer or tennis. All right, so if you form such kind of set where people or friends playing soccer or tennis, that particular set is called union of sets and has a special symbol U. Okay, so this symbol is called union. All right, now what's the meaning of this? Let's try to understand. So soccer, union, tennis. So you want to list the friends who plays soccer or tennis, and if you see there, you see that Alex, Cassie, Drew, and Hunter. So these four are the people who play what? Soccer, isn't it? Now, if you see the people who play tennis, you see that Cassie, Drew, and Jade. So we have Cassie, Drew, and Jade playing tennis, isn't it? See, the people who play soccer are also included in this, and the people who play tennis are also included in this. So basically, union, the very word union means to add up, isn't it? So basically here we have added the members. All right, but here we see that Cassie and Drew play soccer and tennis both, isn't it? So we cannot repeat their name because we know that in a set we cannot repeat the elements. So that's why I have written their names only once. All right, so union means adding up the members in a single set. All right, now not everyone is in that set, isn't it? If you see, out of those 10, not everyone is present in this. Only your friends that play soccer or tennis or both are present in this particular set. All right. Now, in other words, we combine the elements of the two sets, as I said earlier. Okay, now let's see what will be the Venn diagram. Okay, so Venn diagram for A union B. I'm sorry, it will be soccer union tennis will be given by this. All right, so this is the union of two sets, because we see that Cassie and Drew, see, this is the set for soccer, right? So this is my soccer set containing Alex, Cassie, Drew, and Hunter, and this represents your tennis set where we have Cassie, Drew, and Jade playing tennis. So this is your Venn diagram for union of two sets. Now we have understood using the story. Now let's see how do we define union in mathematics. All right. So operations on sets, that is Venn diagram, is my topic, and the first topic that we learned is union. So union is represented in this way. So if there are two sets A union B, okay, if there are two sets A and B, then A union B is defined by this set. That means in this set there will be element X such that this X belongs to A or X belongs to B, or X comes from A or X comes from B, or both. All right, so this is the meaning. Now let us take one example out here. Okay, so I have given you two sets, A equals to 1 2 3 4 and B equals to 3 4 5 6. All right, so A union B will be, just combine the elements. So 1 2 3 4, so all the elements of A are present. Now the elements of B are 3 4 5 6, so 3 4 5 6, they are also present here. All right, now we have combined A and B in a single set, and that set is your A union B. Okay, so let's take another example, that is this one. So A contains element Y and Z and B contains X, Y, Z. So here if I combine both of them, we have X comma Y comma Z, where we see that YZ is also present and XYZ, they are definitely present out here. All right, so this is the simple example that I have given you in order to understand union. Now let's see how do we draw the Venn diagram. So in order to draw Venn diagram, we always need to draw something called universal set. And universal set are always represented by a rectangular figure, okay, as you can see here. So this represents your universal set, and I have written here U. U stands for universal set, or if you want to write Xi, that's also fine. Okay, so in this universal set, there are two sets. As I said, every sets are considered to be subset of bigger set, and that bigger set is known as universal set. So here, what are the two sets? Two sets are A and B. So I am drawing A. So this represents one set. I am drawing B. Now, the Venn diagram for A union B looks like this. Okay, so the yellow portion you can see is the set containing both A and B. All right, so this will be your Venn diagram for the union of two sets. All right, so you may pause the video and note down the Venn diagram. So the next topic is intersection. Intersection is when you must be in both sets. That means you have to present in the both sets. So if you see here, we see that Cassie and Drew are present in both the sets. Yes, so the intersection of these two sets will be how much? It will be a set containing Cassie and Drew. All right, and it is denoted in this way. Okay, so intersection is denoted this way. So that's why intersection of soccer and tennis. Okay, so this means soccer intersection tennis will be what? It will be the elements which are present in both the sets, that is Cassie and Drew. Okay, so here, like in early case, whenever we are dealing with union, there we saw or, isn't it? Soccer or tennis. But in case of intersection, we always see and. All right. So whenever you see this, this means and. Okay. And whenever you see this means or. Remember that. All right. Now let's go to the Venn diagram. Okay. So the Venn diagram will be only the common, that means the ones which are present in both the sets. So we see that only this part is present in soccer's set and tennis set. All right, so this is how the Venn diagram of intersection looks. Now let's see the real definition of intersection. Okay, so intersection, that means if there are two sets A and B, the intersection of A and B is written as A intersection B. It is a set containing those elements which are present in A and presenting B. Alright. Now let's take one example in order to understand. So I'm taking the very same examples out here. So if you see here, among A and B, we have got 3 and 4 present in both the set, isn't it? So that's why A intersection B will be set containing 3 and 4. Now if you see here, we have A and B, and if I ask you what is the intersection out here, you will say that intersection will be y comma z, because in set A we have got yz and in set B we have got yz. So what is common? Both y and z are common, so that's why we write yz out here. Okay, so let's see how the Venn diagram looks. So as I said, you have to first draw the universal set. After that you take one set. Okay, after that you take another set, and the part which is common to both A and B is this, isn't it? So this yellow shaded portion gives you the Venn graph or Venn diagram of intersection of two sets. All right, so pause the video and note down the diagram. Now the next topic is called difference. That means you can also subtract one set from another. So basically we have got two sets out here. So let's subtract one set from the other. For example, let me take soccer and subtracting tennis. That means we'll subtract tennis from soccer. That is soccer minus tennis. That's what we are going to find. Now this means people that play soccer but not tennis. So this is the main point that you need to remember. So people that play soccer but not tennis. And what are the people who play soccer but not tennis? They are Alex and Hunter. So that's why it is written, which is Alex and Hunter. Okay, so that's why soccer minus tennis will give me a set which contains the people who play soccer but not tennis. That is Alex and Hunter. Okay, so let's see what will be the Venn diagram. So Venn diagram will be only this part, because only these people, okay, so only this shaded people are the people who play soccer and they do not lie within tennis. This is the area for tennis and they doesn't lie within this, right? So that's why this will be your Venn diagram for the difference, that is soccer minus tennis. All right, now let's see the definition of difference. Okay, so difference between two sets, that means A minus B, is written as those elements, that is x, which belongs to A, and this x should not be belonging to B. Okay, so this element should belong only to A but not to B. Now what's the meaning of this? Let's try to understand using the very same example. So here the elements I'm finding A minus B. All right, so let us see the elements of A which are not present in B. Okay, so this can also be said that A minus B is elements of A which are not in B. So what are the elements of A which are not in B? The elements of A which are not in B are 1 and 2, isn't it? So that's why we have A minus B equals to a set containing 1 and 2. Now in this example, what are the elements of A which are not in B? There is no element of A which are not in B, isn't it? So that's why A minus B is a set which contains no element, because we have no element of A which is present in B. So that's why this is an empty set. Alright, so that's why I've written 5 out here. Let's see the Venn diagram. So take universal set, draw A, draw B, and we see that only this part of A is not present in B. So basically this gives you the Venn diagram for A minus B. Alright. Now similarly you will be able to find what is B minus A. B minus A means elements of B which are not in A. Alright. So pause the video and note down the diagram. Okay, so the next topic, immediate next topic after learning difference is called symmetric difference. Now I'm not going to relate this to the story which we were learning. Okay, so symmetric difference is represented by this. Okay, so it is called A delta B. So delta means symmetric difference, and this is defined as, first find A minus B and B minus A and take their union. Now let's try to understand this using example. Okay, so I'm taking the same example again. So here A minus B, we already know it is 1 comma 2. Now if I ask you what is B minus A, that means elements of B which are not in A, the elements of B which are not in A are 5 and 6. So that's why B minus A will be this much. Now you have to take union of A minus B and B minus A. So what will be the union? Union means just combine them. So if you combine them, then you have 1, 2, 5, 6. So this 1, 2, 5, 6 gives you A delta B, that is symmetric difference. So for this, we know that A minus B is empty set. We don't have any element in A which are not present in B, isn't it? So that's why this is empty set. And let's find what is B minus A. Now we have B minus A means elements of B which are not in A. Now we have got X in B which is not present in A. X is the only element from B which is not present in A. So that's why B minus A will be a singleton set containing only X. Okay. So what is the union of empty set and X? It will be X itself. So that's why your symmetric difference here will be this much. Okay. Now let's see what will be the Venn diagram. Take the universal set, draw A, take B. Now as you all know, A minus B will be only this much. And what is B minus A? B minus A means elements of B which are not in A. That means only this part, isn't it? So that's why their union looks somewhat like this. This is your A minus B. This part is your B minus A. And if you combine them, you have this and this only. Alright. So this gives you Venn diagram for symmetric difference. So pause the video and note down. Now this is going to be the last operation and we call it complement. Now let's try to understand what is the meaning of complement. So in our case, see, whenever we are dealing with complement, you always need to take care of the universal set. Okay, so we formed two sets and we had set for soccer and we had set for tennis. Okay, but we got those people or the elements of those sets from this set, isn't it? That means the set of 10 best friends. So here the biggest set possible is this only, that is the set of 10 best friend. So that's why I'm calling it to be the universal set. All right, fine. Now as I said, whenever you are dealing with the complement, you always need to work with the universal set. Okay, and there's a special way of saying everything that is not, okay, so that is not means the complement. So complement is, in simple word, is called not of anything. All right, now what's the meaning of this? Let's see. So we have the universal set drawn. How many people are there? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are altogether 10 people within this set. Now from here I am choosing only this much, and these many people gives me the set of people who plays only soccer. That means these are the people who do not play soccer. Yes, so that's why the complement, that is the shaded part, yellow part, gives you the complement of set soccer. So set soccer contains the element or contains the friends who plays soccer, and other than that, whoever is left, they are the people who do not play soccer. And since it is not do not play, yes, so that's why these people form a set which is called the complement of soccer. All right. Now let's try to understand this using the definition. So complement is always defined as a complement. So this is the notation. Sometimes you may have a dash as well. A dash also represents complement, or you can have a bar. All right. So a bar also represents complement, and complement is always written as u minus a. U stands for universal set. All right. Let's take the example. So here a is given. Okay, I am taking complement of only a. Okay, so a complement will be, see, all these are the numbers, isn't it? So you can write all the real numbers. In fact, you have to write all the real numbers except these. All right, so you cannot put this within a complement. All right, similarly you have a equals to y comma z. That means out of 26 letters in English alphabet, I have written y and z. So a complement will be any other alphabets. Okay, any other means all the remaining alphabets other than y and z. All right, so this is the meaning of complement. And if you want to show it using Venn diagram, we have universal set and we have got one set. Since we are talking about only one set out here, so the elements of u, u means this full rectangle which are not in A. So what are the elements of u which are not in A? That will be given by the yellow portion. Okay, so these are the elements which are not present in A. All right, so this is the Venn diagram for complement of A. All right, so you may pause the video and note down the diagram. Okay, so we are done with the operations on sets. So let's see one of the very important topic that is called disjoint sets. As you can see, there is a plural, right? So that means here we are dealing with more than one set. All right. So definition says two sets A and B are said to be disjoint if they have no element in common. There is no element in common between the given sets. All right. Or in other word, I can say that if I take the intersection means we have to note down only the common elements, but since they don't have common element, so that's why I'm writing this to be phi, and phi stands for empty set. That means there is no element common in between A and B. Now let's represent this using a Venn diagram. Universal set is there. I'm drawing set A, I'm drawing set B. Now can you say what is the common thing between A and B here? There's nothing in common, isn't it? So this will be the Venn diagram for two disjoint sets. All right, so pause the video and note it down. Thank you very much.